Okay, let's start with the call. This is Stateless Implementers call number 34. I will share the agenda in the chat. So as a brief summary of today's agenda, first we have team updates as usual. Then we have two 7612 items regarding code conversion and 7702 implications. Then we have two 7748 discussions around empty accounts and the position of the tree conversion logic in the block execution. And finally, 4762 point that I wanted to raise regarding field costs constant. So yeah, as today is a holiday, so maybe not everyone is here. Let's try to simply make progress on the agenda items, and if we feel we would like to rediscuss again in the next cycle on some particular point, we can do that. So yeah, let's start with team updates. I can start. So I worked on publishing some metrics gathering that I did for mainnet regarding potential new trees. This is now in the Stateless book. In particular, I will share the link to this page. Then I also started working on some kind of new witness explorer that we have in DevNet, but for mainnet. This is still work in progress. While doing that, I also gathered some potentially interesting metrics and publish them in some other place. So I will share that in the chat too, if anyone is interested. Won't discuss much about that, but yeah, I think it might be interesting for other people. What else? Yeah, so I'm working also on a document that explains a bit this bytecode chunking problem that is kind of already proposed in 6800, but yeah, I want to onboard more people in the discussion on different approaches to do that, because there are other strategies with different trade-offs. So this document is currently under review and probably will be published in the next days. And finally, I worked too on another page for the book for the 32-byte code chunker that is still under review. So yeah, hopefully will be published in the next few days. So yeah, that's everything from me.
I can go next with the Ethereum JavaScript. So we've made some progress, although not as much as we anticipated last time, because we were still in the yearly release phase where we prioritize like the urgent stuff rather than the research stuff. But I was doing some work yesterday and today on the transition state manager, ask some question in the metrics. We are going to be we're going to start running these tests this week, so I'll be able to provide some feedback this week in the matrix chat. We're going to start with the unmodified accounts, try to run that and see if our client is able to handle that, and then we'll run the modified accounts and see if we can help there.
I guess I'll go. Yeah, I was working on integrating the transition code back into Geth. We had a review. We started breaking things into smaller pieces. So I started coding every one of those pieces. None of them have been merged yet, of course, but that's okay. That's part of the guest process. No worries there. And yeah, I don't exactly recall everything I was doing, but one thing of note, it's a page that has been published in the book that explains how to run a like Geth in dev mode to produce blocks. So if you want to test something in particular, or for example, if you want to test the conversion, that's a pretty useful tool to see, because otherwise, when we want to do a shadow fork, you have to run everything in kurtosis, and it's extremely hard to debug. So if you're ever interested in figuring out how the shadow fork happens, you can use what we call the dev mode, where blocks are produced every 5 seconds. You can spam with whatever tool you want to add transactions that would target things you want to break. But yeah, so now it's explained. If you want to do this, it's still not Geth master, because yeah, I'm still working on merging all that in. But I think it's a pretty useful tool for everyone. Oh, right, and I was also started on the 7702, and I was hoping we would talk about this, but if Karen doesn't show up, probably not. I mean, we can still have the conversation, but yeah, that's more or less what I've done so far.
I think I can go next. So I don't have any significant updates. Still working on making, already made the changes in transition that we discussed the last sick call and after on the chat as well. Now all the tests are passing. And apart from them, still working on merging the workal branch with the Spectra changes. Yeah.
Anyone else want to share an update? Okay. So the first item in the agenda is a follow-up on this discussion we had in the previous call regarding if when touching an account in the overlay tree, if it is possible to convert the code, which is something that today is not really defined. I mean, today in the current EIP, whenever an account is touched, we only convert the account's data, but not the code, because the code is expected to be migrated on the tree conversion EIP. So we have some discussions in the previous call regarding implications of actually doing this code conversion whenever the account is touched. And we had a chat regarding two main things. One of them was implications on the witness size, but also implications on potential worst case scenarios regarding this creating too many writes in the block. So in the previous call, we decided that we have to double check some calculations on this, and I think that Guillaume did that. We concluded that probably is too much load. I know if you, Guillaume, want to mention something about this.
So yeah, I actually made a presentation. If I can find my window, as always, it's code conversion, right? So that should be it. Yes. So I don't know if you guys can see my screen. It's not it's not the most succinct presentation title ever, but yeah. So okay, Ines, you already covered that. We want to know if when you write to an account before it has been covered by the iterator, it has been translated by the iterator sweep. What do you do? So if it's the account itself, like the balance and the code hash, they get translated. What the question is, what about the code? So I was of the opinion that we should not convert the code, but we had real data about this. So we did the computation, and the assumption, of course, is that we use a 36 million gas block, and the current bound of 24 kilobyte for the code size, which, mind you, is under a lot of pressure to be increased. And that means that for a given sorry, my calculation, okay, my math is correct, but my formula is wrong. No, actually it's correct. Yeah, it's 2 to the power of 10. We get for a 24 kilobyte chunk will be translated to what will correspond to a 24 kilobyte code will be broken into 793 31 byte chunks. Now, per se, that's already, like, if we have a stride, an iterator stride of 10K, that's almost 8%. But in the worst case, you could just send one way to many accounts that already have 24 kilobytes, and that gives you a number of the extra number of leaves, which is 1.3 million, about 1.3 million. This is a lot, because I mean it's many times the any stride we were considering. Like, we were looking at 20K, 20,000 leaves, maybe 50,000 leaves, but definitely not 1.3 million. So that would make that would be way too much for the conversion. So yeah, I think that's basically a showstopper. We could try. I mean, there's no way we're going to be able to convert 1.3 million leaves, but even in cases where you just double the size of the conversion, it's not going to be very easy to work around it. Like, I think later in the agenda you have the question of whether the conversion should happen before or after executing all the leaves. But if it's happening before, you find yourself with already 10,000 leaves, 1.3 million leaves, and then you still have to. I mean, you can still decide not to do the iterator sweep, but it's already too late, basically. So my view hasn't changed. We should not convert the code. I did talk to Karim and Tanishq, in DMs about this. I think everybody agrees that we should not convert the code. The question is, anybody else dissenting? I guess not. Well, in that case, I guess that's the end of it. There's another question that's I think has been presented last time, but we more or less agreed that if you only write a slot, you should not translate the account. And I did look into it, and I think it's possible. So I'm of the opinion that, and I think I was the only one against it, that we should not convert the account if only the storage root is translated. I am yet to do to validate it, in a live testnet. But from what I can say, I was the only one against it, and I changed my mind, or at least I agree it's doable. So I will. I think we should do it this way. Yep, that's it.
Cool. I just have a brief question. Can you share again the slides, because I think that the first slide actually had a formula that wasn't correct.
That's definitely possible, because I just left it 15 minutes before this call. Let me find it again. Here it is. Right. Now, is that the one? Yes, that's the one.
Yeah, that one. I think there you wanted to do 24K over 31, right?
Times 31, of course. Yeah, that's missing. Absolutely.
Okay.
Yeah. I mean, this result is correct. It's just that
yes.
Yeah, I did that from memory, so it's still yeah.
Cool. Okay. So as a summary of this discussion, we won't convert the code whenever an account is touched, and in the case that only a storage slot in an account is changed, we won't migrate the account's data. So, okay, that's our good conclusions. So, okay, the next item in the agenda is a bit related to all this, which is how 7702 also is related to this discussion. And as a bit of context, let's imagine the following situation. There's a 7702 transaction which contains an authorization from, let's say, account A to set up the code to some other contract B, right? So in this situation, whenever this transaction gets executed, accounts A code will have a delegation to some other contract B. And technically speaking, this is touching account A only for setting the code to have a delegation. So the question is how to handle this correctly in the case that we have the overlay tree and the conversion hasn't started. So yeah, that's kind of the setup of the discussion. I don't know if anyone has any particular comments, but from my perspective, it seems like like 7702 like creates a new situation on the chain in which you can mutate the code, which is something that we didn't have before for existing accounts. So I think that's like an interesting case that's, we should clarify in the spec. I mean, it looks like if we don't convert anything to the new tree, that means that the MPT isn't frozen because you have to write that somewhere. But from another perspective, we just decided that at least up to now, we wouldn't like do any kind of code conversion in the overlay tree fork. So maybe this might be an exception. I don't know what other people think.
So yeah, I need some clarification here because I don't really see the problem in the sense that if you write the code, then I mean that's not a code conversion per se. You're just writing the code, and when you're going to read, more importantly, you're writing the code hash. So the account itself gets updated because unlike the root hash, this will not. Okay, yeah, I mean, Joachim, I see this, but no chunkification of the code itself is necessary, but there will still be a chunk that only has 24 bytes in it, right? Okay, depends on the chunkification format. But okay, yeah, this is what I meant. But you're right, we don't need to break the code into more than one piece. But what I mean is that when we write that code, we update the account. So in effect, the account is already translated. Now we have a problem in Geth that when we do the consume, that when we get to the code, even if the code has already been written in the tree for whatever reason, we will just translate all the leaves and insert whatever leaf is not already present. So that gives rise to a very weird situation where the one code chunk with the conversion with the delegation will not be overwritten. But actually, I think what I'm describing is not even correct, because in 7702, and I guess that's a question for whoever worked on that more than I did. In 7702, can you replace an existing code? I thought 7702 was only for EOAs. So if that's the case, then you cannot replace existing code with a delegation. Is that correct? You can't replace smart contracts, right? So then...
But wait, let me make a comment here, because I think this is getting a bit in the rabbit hole before.
Okay.
So my question is the following. Like, we have a 7702 transaction which set up a delegation for an existing EOA.
Right.
My question is, should we write this delegation in the new tree or not?
Yes.
So this is like an exception to this previous discussion that we have in the previous agenda item, right? There's like
No.
now there's like a case in which for an existing EOA, we will do a kind of code conversion.
Oh, okay, I misunderstood. So you mean when we have an existing delegation, right? And we did not, but it hasn't been written, like between the time the iterators start sweeping and the moment this thing gets converted, we don't, like, it hasn't been written. That's no, right? You're saying if
No,
we do
I'm
the
saying
translation-
that we have the overlay tree and the conversion hasn't started. Okay, we are in that case. So we have a 7702 transaction which writes this bytecode designation into an EOA.
Yes.
Okay, so this is like a situation in which you're writing code to an EOA that already exists. So in
Right.
theory, we should decide what to do about this. We should write this new designation in the new tree, or kind of what really?
Yeah. I mean, like, the MPT is frozen, and a lot of things rely on the fact it's frozen. So we need, whatever we write to the tree, we need to write to the overlay tree. That's for sure. But then I don't really understand where the problem lies.
No, it's not a problem. It's just like a case in which it's the only case now that we will write code in the overlay tree situation. Like we just discussed that we wouldn't change, we wouldn't do code conversions.
Right.
But I think that with 7702, there's like the only
Right.
case in which we will convert code in the overlay tree. Just like making that point more clear.
Okay, I think I understand, but just okay, maybe Milos wants to speak first.
I mean, if somebody deploys a new contract, we would write the contract in a new tree. How is this different than that case?
Well, that's like a new contract. Like it's like a new account. For that case, it's fine. But before 7702, for existing accounts, we didn't have any case in which we will convert existing code. Like this is just like a new situation of 7702, like being able to add code to an account that already existed. So it's, I think, should start.
But we would not be converting existing code, right? We would just be overwriting the existing code with a new delegation. Like the old code would not be converted until
this, let's see, the old code would be potentially another existing delegation, right?
The old code would be a potential existing delegation, but it would, when the iterator sweep happens, it needs to check the destination tree to see if something is already there, which it does already.
But there's no iteration sweep because I'm talking only about before the tree conversion.
Before the tree conversion.
I'm always talking before the tree conversion, only when the overlay tree is active.
Okay, right. So if that's the case, let me just say it out loud. Right. So you have an existing delegation, and then between the moment the account starts, the fork starts and the sweep starts, you have a week in which a new delegation happens. I get you correctly, right?
Yes.
Okay. So then the delegation is written in a new tree, in the overlay tree. And then, but the account itself would be converted. That's true, because I guess logically you override the code hash, even though it's the same.
Yeah, that's what's going to be my next question. It's like, okay, it seems pretty clear that the delegation should be written in a new tree because the MPT is frozen.
Yeah.
Maybe we could only do that and not migrate the rest of the account data.
Yeah.
But I think that would be wrong, right? Because the nonce would change. So that's an indirect account data, right? So we should probably move everything.
Oh, you burned the nonce.
Yeah, that's fine. Yeah. So we should probably convert everything.
End of story. No, I think there's another case though. It's when you replace it with a zero. Because right, it's possible to delete the account. To set a code to zero, by which it means it says you should then set the code hash back to empty code and then write a zero. And I think this could be a problem because we want to make sure that if we read the delegation, we stop at the zero and we don't go back to the old tree to get a delegation that no longer exists. I think it should work, but we have to double check that, or at least I have to double check that.
I think a similar thing happened. We discussed this before as well in S store as well, because in Workl, like empty and zero are two different things. So I think there also we discussed that we need a different mechanism to make sure that something is zero and something is empty are like two different cases.
Yeah.
For Workl.
I mean, that's the thing. You're right. That's the same conversation, because if you write a zero, then you are being returned a zero, and that's the end of the story. You can detect this. But if we start doing, like Gary wants to, if we start doing deletions in Verkle, right? Okay, so that's a global problem with the overlay tree. We have to mark deletions, like you said. Okay, no, I guess there's no problem. Yeah, it should work as well. Tested, but it should work.
So wait, so if you try to remove an existing delegation, you say that can be solved without supporting deletions in the tree?
Like if you don't support deletions in the tree, yes. Because when you look, okay, I'm gonna do some guess internals, and I'm sorry for that, but when you look at the transition tree, right, it first goes into the Verkle trees and sees if the return value is nil or zero. If it's nil, that means it's not there. It goes to the MPT. But if it's zero, it says it's zero, and then it returns zero, which is what it should do.
No, but I mean after the conversion is done.
So after the conversion is done, you would have a zero, but yeah, it would be the same thing.
So you have like, you want a way to set that the bytecode is not set, not really that it is zero, because it's not zero. It's not zero bytecodes, right?
Well, it is
more like there's no delegation.
Right, there's no delegation, but the bytecode, the code hash is still empty code, and the code size will be zero. So you have a chunk, yes, which is filled with zeros, if you will, but it's not like delegation is deactivated. So this is what you want.
So it's actually setting the code size to zero, basically.
Oh yeah, it has to, yeah. Like if I remember the spec correctly, but yeah, I guess Joachim can chime here. When we have a delegation that is filled with zeros, we write that zero, which in the MPT world means delete that entry from the tree, but in the Verkle world or stateless world means we are just writing a zero in that leaf. And then you have to set the account back to being a regular AOA. And in the MPT world, that just means set the code hash to empty code hash, like CD5, blah, blah, blah. But in Verkle world, that would mean set the code hash to empty code hash and set the code size to zero.
Cool. Yeah, that makes sense to me. I don't know if anyone else has a comment about this topic, or we should move to the next one. Okay, so before that, I would say that we should probably create a PR in the 7612 to clarify a bit more what's implications of 7702. I think that Guillaume was thinking about updating EIPs to, considering general 7702 implications. But yeah, I think helping a bit more EIP readers on this case will be helpful. Okay, so the next item in the agenda is related to 7748, which is the tree conversion logic on how to handle empty accounts. So a bit of context here, the way that 7748 works for empty accounts is just deciding that it won't convert them because, these accounts have this rule that whenever today you touch them, you are expected to remove them. So the tree conversion was an opportunity to just like avoid converting them because we want to remove them anyway. And when I was writing the tests for the tree conversion some weeks ago, I realized that, I've heard that these accounts do not exist anymore in mainnet already. So I started asking some people about this, and I think some people were still arguing that some of these cases exists. But on Saturday, I think I was talking with Hochem, and he mentioned this EIP that I will share in the chat. Oh, thank you. So it looks like from this EIP that all these cases were removed around block number 14 million or so. So the question is, if none of these cases exist in mainnets, can we like remove this rule from the tree conversion of not removing these cases because no cases should be found? That's kind of the general question. I know that other people think that maybe this rule is better for other networks to apply this tree conversion because maybe these cases exist on other networks or maybe in devnets or something like that. But the only my ultimate intention is trying to see if we can simplify the tree conversion logic a bit more by removing this rule if it's not really needed. I don't know if anyone has a comment about this.
I have one. I was just hoping someone else would have one too. My comment is that I'm not sure we're talking about the same thing here. Gary created that EIP 61 something 6110. I forgot. No, that's something else. So he seems to think that those accounts still exist. I wonder if, and at the same time, the EIP, like when Peter Davies did this, Peter Miller now did this, he created a transaction to actively delete them. But according to Gary, there's like 28 accounts, and the transaction that Peter Miller did has many more accounts than this. So either Peter forgot some of the accounts, or we're not talking about the same thing. And I think I've been trying to get some more info from Gary, but I didn't get anything really conclusive. So I think the best way to do it would be to check, a database of any archive node. Actually, you don't even need an archive node; you just need a database. And we could just check. We could just check if those those accounts exist still. If they do, well, we keep the rule. If they don't, we just say we just tell Gary that his EIP is no longer useful, and we close. We delete it.
Is that the EIP that like empty account deprecation?
I didn't quite hear the IP that.
Is this the EIP concerned with empty accounts deprecation? Just trying to find the EIP so I can refer it.
Yeah, it's. I mean, I can look for it. Just have to look for
7523, I think.
7523. No, 7610 is the one I'm talking about.
7610. Okay, thanks.
This one. Oops. Yeah, 7610. Honestly, okay, that's weird. I can't copy the date, the link. Okay, done. So it's a river creation in case of non-empty storage, right? So that's the thing. According to Gary, those accounts still exist. Yeah, Johan.
Yeah, the main topic here is also about like the empty accounts, right? Because I think these accounts with storage in them, they also have a nonce of non-zero, I think.
They have a nonce of non-zero. Well, that would explain why they were not touched by Peter. So yeah, that would explain why. That would confirm we're not talking about the same thing between Peter Miller's EIP and Gary's EIP. Okay,
Yeah, it's
I
not
guess
the same.
we're a bit confused. I think we should just look for those accounts, and I can do it if no one else is passionate about this. But I guess right now we're just shooting in the dark. So let's just look for it and come to a conclusion.
Yeah, I think also for the ecosystem itself, it would be very nice to just know, like, are all these empty accounts deleted? And though we have like this very weird case of empty accounts, so that means zero balance, zero nonce, and the empty code hash, but with storage in it. So like the non-empty storage hash. That's also very interesting. So it would be very nice if we would all know that. It would be really great if that would be what we do. Yeah.
Cool. Yeah, let's confirm that, and we can try to reach some conclusion maybe in the next cycle. Nice, amazing. Okay, the next item in the agenda is related also to the tree conversion, which is the position of the tree conversion logic in the block execution. So why is this a topic of discussion? So when I was creating the tests, I realized that in the EIP, we defined that the tree conversion, well, let me double check this and I will share the link in the chat. Is 7748. So if I recall correctly, we defined that the state conversion happens before the transactions are executed. Yeah. But when I was writing the tests, I saw that Geth implementation actually has this code after. But after thinking about that for a minute, I realized that the actual position of the tree conversion in the block execution doesn't matter, because whatever write happens in this tree conversion, it has like a lower priority compared to any other write that might overlap in the transaction execution. So no matter if you do the tree conversion before or after the transaction execution, from a state root calculation than after, it should be relevant. So I think that we originally decided to put this before the transaction execution because we wanted to somehow hint that execution clients can actually do the tree conversion work before the actual block comes, because this is like deterministic work that you can do even before knowing which transactions will happen. But this is also the case even if we decide to put this logic after the transaction execution. So I don't know if anyone has any thought about some other reason why the order or the position in the block execution matters, or if you have any preference on it. I think you wanted to touch on this on some previous discussion, but
Does this
go ahead.
yeah, so for 7748, I have not read this EIP completely, but is there also like gas cost in them if you write to state which is not yet converted in a transaction? Is it like more expensive or not, or is the same price?
It's the same price.
Okay, then I don't have any point here. Yeah, cool.
Yeah, so I think my position has always been that, it's practical to do the conversion after, but ultimately we should move it before, like when we get closer to shipping Verkle on the testnet, on the mainnet. And when I say Verkle, once again, I mean stateless. Just have to lose that habit. But now there's the idea of delayed root execution. And I think it's actually playing, or at least I get the feeling this is playing against it, because if you do the conversion before, you need to wait for someone to give you the block that you can build on top of. Actually, it's the same. Yeah, it's completely, yeah, right. Because you would have more time to do it anyway. I guess, yeah. I think it no longer matters if we have delayed root execution. We can leave it after, but if we don't have delayed root execution, we would have to move it before. That's that's my position.
But my question is, like, from a spec perspective, the end result will be the same, right? So you can, like, at the implementation level, you can put it whenever you want.
Yeah, it would not make any difference because when we do the conversion, if we do it before, whatever is used in the block, whatever is then written to in the block is like overwrites what was written. And if we do it after, we have this code that we go and check the tree to check that if we're converting something, it hasn't already been translated. And that needs to happen no matter what. Even if we put it before, we still have to do the check. So it doesn't, it doesn't matter really. It really makes no difference.
Yeah. Okay. So there's like actually no reason to move it, really. I think that's the conclusion.
Yeah.
Okay. I know if anyone else has a comment on this. No? Okay. So we will keep things as they are because there's like no good reason to change things. And your clients can put the logic in any place they prefer because it's like an implementation detail. Okay, so let's see then. There was an extra item in the agenda. I closed it up. Yes. Give me a second. Sorry for that. Yeah, so there's the last discussion is about fuel costs. We have 13 minutes. I think that's maybe a bit tight on discussing this, but yeah, I think I will do it anyway. I have some slides. Give me a second. I will share my screen. Okay, hopefully you can see my screen.
Yes, we can see it.
Yep.
Okay. Yeah, so I have a few slides to explain this a bit more. So the context of the discussion is, let's imagine that we have a new tree and we have a call, value-varying call, which will create a new account. Okay, so that's kind of the setup. So currently in mainnet, if you do this kind of call, you will be charged at least 25,000 gas because, yeah, you are creating a new account and that has an extra cost. And the way that the current DevNet for Berkel behaves is that we still have this 25,000 gas cost, probably because we don't yet have implemented field costs. So I think that's kind of the interpretation of today's reality of the DevNet for the stateless situation. Okay. Now, in an ideal DevNet, when field costs are implemented, okay, so first of all, we should remove, I would guess that we should remove these 25,000 gas costs, and we will charge 2 field costs, which will be the basic data of the account and the cold hash of the account, right? So each of them is 6,200 of gas, and that means around 12,400 gas, which is way less than 25,000. So this felt a bit weird to me, because that means that creating new accounts via value varying calls will be much cheaper. So after thinking for a minute, I realized that maybe this is this actually indirectly happened when we decided to pack the nonce balance and code size in the basic data field. Because before we had basic data, we actually had 5 different values in the leaf, which were version balance, nonce, code hash, and code size. So those would be actually 5 field costs, which in this case is more or less like at least bigger than the 25,000. So that made some more sense on why this happened. I think it wasn't intentional, and it was like a side effect of this packing that we did with basic data. But actually, if you look at, okay, how this behaves with storage slots, whenever you create a new storage slot via Nestor, today in mainnet, you would be charged for a cold access as usual. You will be charged 20,000 gas for the new value, which adds up to 22,100 gas. But with 4762, you will be charged, all this stuff, which is like the branch access, the branch write and chunk write, and the new value, which is the field cost. And if you sum up all this, you will still be paying half of the current mainnet costs, which sounds a bit odd too. So this seems to be that at some point in the future, we have to reconsider maybe the current field costs constant of 6,200, because it's making new storage slots have half the cost of today. And with the basic data packing, it's also around half of the previous cost of creating a new account. So I'm not like particularly concluding that we should double the field cost gas, but we should actually think a bit more on this topic, because something looks a bit odd, unless we decide that we want to make these actions cheaper, right? But I think this wasn't the intention of the gas reform. That's mostly it. I don't know if anyone has a comment about this.
I have a purely nitpicky comment. I don't think the understanding was that it would be cheaper. I think some of it was understood to be cheaper to compensate for the fact that code execution would be way more expensive. That's a completely irrelevant comment, but just wanted to point that out.
Yeah, okay. So let's just simply keep this problem in mind, and maybe in the future, whenever we polish the AP constants, reconsider the current gas costs.
One question regarding this: is every team sending someone to the interop? We're not gonna say where it is because it's a public call. But is every team sending someone to the interop?
Can we say when it is so that we know which one we're referring to?
I can tell you privately.
All right.
It's a Northern European city.
Yeah, I'm not going, but I think we have someone.
I will be there.
Excellent.
Yeah, cool. Yeah, maybe let's chat about this topic there if you want to think about it a bit more. Yeah, and that was the last agenda item. I don't know if we have like 5 minutes before the call ends. If anyone wants to raise some other topic, I just want to say that we are trying to find a new spot for the C call because looks like the testing calls also happening on Monday will be extended by 30 minutes, which means that it will have a 30-minute overlap with the current C calls. I did try to gather people's availability last week on trying to find a new spot, and it seems to be quite tricky. I know, maybe we will have a bit more time to find a solution to this, but yeah, we're trying to see if we can move the call, or maybe instead of making it bi-weekly, making it weekly and half of the duration. We are still thinking about it. Just wanted to mention this topic.
Would you happen to have the Let Us Meet link that we could share here? I don't have it handy, but yeah, if you haven't filled the Let Us Meet, also inform us, please, of what you want, what you would prefer.
Yeah, I shared this in the chat. Yeah, if you don't mind, try adding your availability so we can try to, yeah, figure out a good spot. Okay, so if there's no other comment or topic to be discussed, I think we can call it a day. Thanks everyone for joining. Yeah, see you next time.
Thanks, Ignacio. Happy Easter.
Thank you. Bye bye.
Bye bye.